Muchas gracias a todas las autoridades que nos acompañaron en esta inauguración y vamos a dar paso a la primera conferencia de este evento. Innovación, reduciendo la huella. Nuevos desafíos para la gestión hídrica en un mundo que ya no acepta excusas. Una vez inaugurado el 18º Foro de la Economía del Agua y la 5ª edición de Expo Agua, vamos a dar inicio al programa de esta primera jornada con una invitación a todos ustedes. Sigamos conectados también en el mundo digital, compartiendo ideas, reflexiones y momentos clave a través de los hashtags Expo Agua 2025 y No hay agua que perder. Y ahora sí, sin más preámbulos, damos comienzo a la primera conferencia del día titulado, como les dije anteriormente, Innovación reduciendo la huella, gestión hídrica para un mundo que ya no acepta excusas. La moderación de esta sesión va a estar a cargo de la doctora Camila Bettinger, una destacada académica y profesional del ámbito jurídico-ambiental. Ella es abogada y doctora en Derecho por la Pontificia Universidad Católica de Chile, con especialización en Derecho Ambiental, de Aguas y Administrativo. Actualmente es investigadora del Centro de Derecho Regulatorio y Empresas de la Universidad del Desarrollo, donde combina la docencia con la asesoría a proyectos de inversión y organismos públicos y destaca por su enfoque en regulación económica y recursos naturales. Bienvenida, mi querida amiga Camila, al escenario.
Hola, buenos días. No sé si se escucha bien. No me aplaudan a mí, la verdad es que yo solo vengo a presentar y a una invitación que nunca le puedo negar a la querida Claudia. Estoy muy contenta de estar de nuevo acá, ya he venido varias veces a escuchar sobre todo cómo se renuevan acuerdos, se prometen cambios y se presentan soluciones, que es parte de lo que me toca en la conferencia de hoy. Me toca presentar a Ian Ramsey. Ian es consultor internacional en tecnologías de zanja, que en inglés se dice trench, right? Zanja. The trench technology, o sea, como tecnología sin zanja. Es consultor internacional en esta tecnología, con más de 25 años de experiencia en el sector. Ha liderado proyectos de rehabilitación y construcción de infraestructuras subterráneas en América Latina, Europa y Asia. Especializado en soluciones sostenibles para redes de agua y saneamiento, ha trabajado con todos los actores, gobiernos, empresas privadas, organismos multilaterales, y en ese rol también está acá con nosotros. Es conferencista habitual en congresos internacionales y asesor técnico en normativas del sector. El enfoque que nos presenta combina innovación, eficiencia y cuidado ambiental. Ramsey también es formador de equipos técnicos y promotor del uso de tecnologías limpias en la gestión urbana, por lo que su presentación creo que es muy adecuada para todas las cosas que se dijeron en la inauguración. Ian, it's a pleasure to have you here. I'm going to switch to English for the presentation. We're going to hear you and then we're going to talk a little bit. I just present you, so now the floor is yours.
Muchas gracias Camila. Muchas gracias for the invitation for the Expo. Today I'm going to speak about innovation in reducing the carbon footprint and the new challenges using trenchless technology in water management in different parts of the world. So the prolonged droughts that we've had in certain parts of the world, the rising temperatures, you've probably seen a lot of problems in Europe, and we've also seen cities growing faster than ever. And we only have 3% of the Earth's water is fresh. And we've got a failing network globally, not just in Chile, but around the world. Are you translating?
I have to know? I can? Okay. No, I don't have to translate. They're going to hear you in English.
It's okay. It's just all in English. Okay. So managing water is no longer optional. So we've got to think about the climate change and how we can take the technologies to the next level. So there's a lot of innovation in different parts of the world. And the traditional maintenance of digging things up can't keep up with the challenges of networks today. Trenches solutions are used a lot more globally. They reduce disruption, they reduce carbon emissions, and they reduce the costs. And when people have such a wide network and an only limited budget, you have to think about the consequences. We're looking at AI, inspection tools. We'll look at things like cured in place, and basically the global city growth and how we can adapt and take care of our precious assets. So trenches technology. These are civil methods that basically that install and repair underground networks. It can be gas, it can be drinking water, pressure pipes, sewers, without digging them up. It has an exceptionally low carbon footprint. So basically we're looking at reducing the environmental impact when we can compare it to evasive action. We're also thinking about upskilling labor, so people involved in this are not the traditional guys who are digging, they're learning new skills and upskilling. And we're taking old pipes and we are extending the life of these new pipes. And again, as I mentioned, we're looking at sewer, water, oil, and gas. So you can see over the years how global trenchless technology from this only goes up to predicting up to 2033, but it's relatively growing about 15 to 20% globally, with main areas in Europe, US, Australia. But here in South America, the two big countries that are pushing things forward are here in Chile and Colombia. And Chile is really paving the way for the future, and they're investing and learning about the technology. So when we look at trenchless, you've got this general term called rehabilitation. And we break this down into renovation, replacement, and repair. And I'll go into a little bit more detail later on. Everything can't be trenchless. Sometimes you have to do some digging, and other times you don't. You can just do it completely trenchlessly. So the key is the 3 R's: replace, repair, or renovate. And we're looking at solutions and how do we come up with these ideas onto why should we use that technology as opposed to that technology. So the world of trenchless, these are examples of when things aren't done and we get it wrong. And I'm going to show, this was recently in South Africa. My friend was working on this project. This was on the news because they weren't taking care of their assets. And that is a real activity. 1 person died, 48 injured, because they did not know what they had, something went wrong, and that was the result. This is the aftermath. A main street in Johannesburg. It's probably still like that because they haven't done anything. So trenchless technology. Growth in cities from 1950 to 2020, you can see the huge growth in different cities from the UK, Poland, France, everywhere. All these people, they still need assets, the wastewater system. They've got to have drinking water. They need to have the assets that cope with this growth. These are the major cities in Europe. Istanbul, 12.5 million. Moscow. London has grown phenomenally. And I'll talk a little bit about some innovations that they've been doing in London. We can go all the way down there and see these people have to live somewhere. They have to eat, drink, and everything else. And the network must cope with what they've got. We're probably familiar with how a sewer system works. So we've got some wastewater. It goes through, it's basically screened, and then we try to basically separate everything out. You're separating the solids, you're separating the water. The water can be then reused and infiltrated. The country of Singapore is one of the most innovative countries when it comes to dealing with wastewater. They basically transfer it all into drinking water because they do not. There's 6 million people on a small island. They don't want to be reliant on Malaysia or Indonesia. I lived there 6 years working, and they had so many new ideas on how they can cope with the wastewater system and be environmentally aware. So this just gives you like an overview. And whether it's Santiago, whether it's Bogota, whether it's London, the systems are generally the same. There's slight variations. Now, with climate change, we get what's called wet weather impact. So if you've got a network and it starts to rain, not just rain, but heavy rain. Australia recently, the winter here was very wet. Well, what happens is that the water seeps into the network. You've got a treatment plant, so the volume going into the treatment plant, including the increased growth in population, is going whoop. So the treatment plant can't cope. So what happens? It goes bleh, and sewage goes into the surrounding water. So when people want to go fishing, or people want to go swimming, and in the UK at the moment, there's a huge backlash because you're walking on these lovely hiking trails, lovely lakes, and what do you smell? Not very good. And politically, they're under a lot of pressure at the moment. So sewer spills are a major source of water pollution, environmental impact, that harm wildlife and people. And there's a lot of what they call legal discharges, but there's a lot of illegal discharges. And in the UK at the moment, the water companies are being fined very heavily for illegal discharges. Some people, if you want to say politically, they should be using that money to reinvest in the network and improving it, but that's another story. And we also have a lot of poor functioning treatment plants, so they can't cope with this volume. So you've got a city growing, you've got increase in population, you've got wet weather impact, you're going to have a problem. So I don't know if you were watching the Olympics last year. The opening ceremony, one heck of a rainstorm. It was coming down in buckets. What happens? It all goes in the Seine. So one of the events that they're going to do for the swimming and stuff, they had to delay it because the guys couldn't go in the water because of all the pollution that was caused. So it's pretty relevant. Now, if you're a water company, when you've got assets, you've got to think about what you have. You own those assets. The key is to understand what you've got, how bad it is, and then what you need to do to make it better. So I'll basically put this sort of program together. You have to inspect. Now, we'll go into a little bit more detail. There's so many different ways of looking at what you've got. And this can be non-invasive inspection. Once you have that data, you can then start to think, you bring in the experts, what can we do? What don't we need to do, and what do we need to do? It's like when you go, you've got a pain of some sort, and you go to the hospital. Now, they say, take a pill, but does that sort the problem out? That's why they do things like MRI scans. So you look at the whole body and say, what is the fundamental source of the problem? So it's like having that pipe burst, but do we really know why it burst? What caused the burst? What was this, that, and the other? So we have to go into a little bit more detail. And we call it condition assessment. You're understanding what you've got and how bad it is. So it's like an MRI scan with a doctor. I think that's the easiest way to understand it. But there are so many technologies that are out there. I was looking at some on the stands today, and these give indications straight away of not just a CCTV camera, but what we've got. If you're the water company, you've got a thing called risk assessment. So I put a little chart here, and at the bottom, you do nothing. So basically, we're looking at the consequences of failure versus, basically rehabilitation. So the do nothing, you've got a good network, it's working well. Then, as it ages, you've got to start thinking about monitoring it. We start to do more investigation analysis, and when it's really bad, act now. If we take Germany, Singapore, and say UK, when the companies issue a contract to a company like hydrica or whichever, Veolia, they have it in two parts. One part is the planned work. So this is work where you're basically in the monitoring area. You're looking long term, we're going to rehabilitate that, we're going to do this, we're going to do that. The second part is emergency work. Because suddenly, boom, you get you're flooding the street. You've got to repair that immediately. So you've got to basically have a reactive work and a planned work. Unfortunately, because of the aging networks, the reactive work is becoming more and more because things are failing, so the money has to go from the planned works, is getting less and less, and it's going into the, basically putting bandages over things. So a lot of inspection is done with, you want to see what's out there. So there's a lot of camera systems that exist, and these cameras go in, they look where the cracks are, how bad things are. They don't always understand what's around the pipe. Last year I was in Rio de Janeiro, and in Rio de Janeiro we were working on some things, and they have a lot of sandy soil. Now the problem is they put like a very bad cover on it for the roads. So what happened was, with all this rain, and because of the sand, it gets washed away. So what happens is the pipes are sort of not very, very good. And when a pipe has got it's the gravity of the pipe, and it's got nothing around it, a void, the pipe goes, and what happens is the whole thing falls in. You get a sinkhole. These are becoming more and more apparent, and it's due to the soil. But there are ways of ground penetrating radar, looking at holes where things can blow up. And there was a guy on his bike, he went straight into the hole, And this is due to bad management of the network. You can't do it, at the rain, we can try and limit the rain with global warming, but it's still going to happen. It's how we manage it and how we take care of it. So these are lots of different systems. There are also systems where you have a live pipe and you put like a special ball inside, and it'll go along and it monitors the flow, the thickness of the pipe, the condition, the ovality, and you get a lovely 3D model. And this is something I'm working with one of the teams out here on, which is fantastic. It's getting a better understanding. We do a lot of laser profiling as well, so you can see the ovality of a pipe. Because if a pipe is not round, and you start to get like deformation, if it goes more than 10%, that's a big problem, because that pipe can collapse. But it's understanding before. And sometimes when you look at a pipe, they say, well, how long is it going to take for that pipe to fail? I don't know. You can guess, but you don't actually know. So you get to the point when you say, should we do something or should we just leave it? And unfortunately, politically, people say, well, I haven't got the money. And then things collapse and, we need to do something. We'll find the money somewhere. That's a different question. When surveys are undertaken, the detailed information is there. We can see on there how, here we've got some guys in Chile. They'll produce these sort of reports so that it's all understood. However, I was working in Toronto, and they're putting a bid out. Great, the bid's going out for some rehabilitation work. And they said, we've got all the CCTV. And I went, hang on a minute. What's the date on the CCTV? It was 10 years old. I said, do you think in 10 years it might have changed a little bit out there? And it was like, so the first thing before you bid, you've got to go and re-CCTV everything. You've got to have the best available information at the moment. So these are examples. If you've got pipes like this, you can do some rehabilitation. A lot of pipes where you've got high groundwater, It's coming in, it's causing a lot of problems. Here we've got brick sewers and brick problems. A classic example was in London about 3 years ago. The main line going into Waterloo Station, where all the commuters are going in every day, they found an egg-shaped sewer 3 meters down. Just routinely looking through, there was a brick going like that. So they all started to panic a little bit. And what happened was, if that brick fell and the sewer went down, it would stop the rail. The whole rail network would stop. So they had to secure it. There was a penalty of €1,000,000 per hour, because they would have had to have buses, they've got to do all of this. So it got people's attention. They stabilized the pipe, they used various technologies, and lots of people ran around, headless chickens and things, but it was all sorted. But it should never have got to that point. It's just understanding what there is. There's a lot of laser profiling now. We tend to try and get a better understanding of the 3D modeling of the pipe. So all of these technologies exist. We've got AI software where you can actually put the camera through the pipe, use AI to automatically code the pipe. So instead of spending weeks looking at videos, you can do it in seconds. And that's one of the AI applications that's really starting to develop now. And once you understand the information, you've got your planned, as I mentioned before, you've got unplanned, which is always going to happen, and then you've got your total maintenance costs. So it's actually trying to balance everything in there. And of course, when we've got people like Thames Water in London, who are sort of 20 billion or whatever, they've got a problem. It gets into a different ballgame. So, applying a trenchless. So we know we've got problems. There are lots and lots of solutions. Renovation is where you use the existing pipe structure. Replacement, well, you basically take one pipe out, put a new one in. Repair, again, you use the existing pipe structure. So when we renovate, we have non-structural and structural. And I could go into a lot of details on the two differences, but it takes a while, and I don't think it's applicable at the minute. But underneath them, you can see the different types of solutions, from close fit, CIPP, you've got epoxy spray lining, open cut, which we all know, you see it just walking around here, trenchless, directional drilling, pipe bursting. We've got slip lining, so there is a lot of different trenchless areas there. It's just knowing what tool. We have a big box, we have a problem, let's use that tool or that tool. That's a decision that we have to make as a team. So the most popular solution about is called cured in place, which people may be familiar with. It's where we take a material, we add a resin to it, and it's cured. A lot of it here in Chile is using light to cure it. It's very environmental. It can go on pipes up to probably 2.4 meter. So here we have the pipe, we have the CIPP, we call it cured in place, inside, and we get a tight bond. Now that is tested to about 50 to 100 years. And there's a lot of testing on weight, we look at abrasion, we look at chemical resistance. So there's lots of different resins. And the finished product is usually round about, I would say 75 to 80% of it is the resin, the other is the carrier. But I'll go into a little bit more detail on this. It was invented in the UK in 1972. And it's literally been used all over. It's probably in about 90 to 100 countries worldwide it's been used. And the US, which we'll go through, is the biggest user of cured in place. But technology has moved on. It used to be basically leave it in place for about a week, let it cure. Now we can cure it in 2 hours. Now there's a system you'll see in there that can cure it in 10 minutes. And it's really, and a lot of that is to the supply chain who've invented and developed things. So these technologies exist. So if we take a snapshot of cured in place around the world, North America is about 46%. Europe, it's a lot. And we're looking at about 18,000 kilometers go in the ground. So we're not talking something small here. China is growing like mad, 8%. Rest of Asia, Middle East, small. It depends. It's starting to grow. And then the rest of the world. Here in Chile, there's about, I think, 75 kilometers per year, roughly done. In Colombia, there's quite a lot. Brazil, not so much. But it is, when we're looking totally of about 17,000, that's a market size of $3.5 billion US dollars a year. That's a global market. So hence, there's a lot of innovation. There's a lot of investment going in. Facts and figures. To date, after the first installation over 50 years, there's over 200,000 kilometers of this stuff in the ground. So it's not new. And that's 125 miles for the Americans. And this is equivalent to 5 times the lap of the planet, or if you take that car there, which I don't know if anybody's got one, it's going to take you 19 days to drive the full length at full speed. Just facts. So this is where a lot of the work is being undertaken. Brazil does have a lot of microtunneling going on. US, they do everything. Europe is very, very innovative. There's a lot, Germany particularly, a lot of development work there. China is just, boom, they're bringing a lot, but they haven't learned a lot of tricks. They're very good in certain areas, they're not in other areas, but they will grow, and the market's fantastic. Japan, I spend a lot of time in Japan. They do everything step by step, but everybody has the same fundamental problems. We're now, and this is coming into Chile very soon, we're now looking at pressurized systems. Pressure is very different to gravity. CIPP is mainly gravity. When we're talking pressure, we're working on a project with Petronas in Malaysia. You're talking oil, you've got hot water. Gas, I'm in Colombia next week on gas. Water, which is drinking water. And this is what we're talking to people here on. And again, it's a trenchless solution. It's very, very environmentally friendly and has a very low carbon footprint. Plus, you're upskilling the teams. So you can see the global market. This is taking all the technologies into account. We're looking in 2029 at about 6.5 billion. So this is like if you were a supplier and stuff like this, but it's educating the cities, educating the countries, and getting them to start acknowledging, because it does work. What they did was the first CIPP liner that was ever put in the ground in 1972. What they do is about every 5 years, some guys go along and they go down and they take a sample of that CIPP and they test it. And this is, because everybody says, oh, 50-year life, but this is actually over 50 years. And they check the properties under testing, and they're amazing. They are really still there, and it's still working well. So, it shows that this technology is a long-term solution. So the challenges we have, we've got the global warming, we've got the extreme weather conditions, we've got population growth, city expansion, and we've got super demands on the system and the network. So we'll talk a little bit about the rainwater, which we're all getting. 71% of our planet's water is water. 71% of this planet, okay? The oceans hold 96.5%. Water is either, you've got 2 types of water. You've got fresh water, or you've got salt water, or you've got frozen as well. So 97% is salt water, and only 3% globally is fresh water. And 2% of that 3, so basically, is frozen. It's in these, which, in Patagonia and places like that. So we've got to treat water a little bit special, And when we're looking at things like rain coming down and how to capture it, and I'll talk a little bit about that, And then we're looking at wastewater and how we can actually manage wastewater and take the water out and use that again, like they do in Singapore. We've got to think about that. But when I was putting this together and I looked at those numbers, I was shocked. I didn't realize it was so small amount of fresh water was available. You probably saw in the news California recently, all the wildfires. And California, believe it or not, beforehand, had record rainfalls. Guess what happens to all the rain? Straight in the Pacific Ocean. There's no rainwater capture. If they had at least a small amount of that, they could have tackled the fires a lot easier. But the place is dry, you know? Rainwater capture is more and more becoming so much more important. And rainwater capture and harvesting. I was in France last week, and it's dry. But they've got a lot. Farming takes up probably 80% of the economy in France. All right, we like to compete with the wines from Chile to France. We all like to have a little bit of fun. But they utilize the rainwater to capture it so they can reuse it. In the UK, we typically have rain buds, and we basically water our garden, if you want to, of plants with the rainwater. You capture it. It's pretty standard. In California, zip, nothing. But there's a lot of opportunities. I'm just pointing it out. We get a lot of these freak storms where it causes a lot of problems. But where's the water go? What happens to it? And that could be utilized in a better way. And it puts stresses on the systems. So what they did in London was they came up with this amazing plan. We've got a huge population growth. We've got an aging network. So they thought, let's think outside the box. They came up with this program, and it's basically called the Thames Network. So they basically, in parallel, they built this it's like a subway tunnel. 80 meters down, 4 meters. They did a total of, and it's about 45 kilometers. And so it basically, a lot of the sewers drain into this. It goes all the way along to a place called Beckton, and they've got pumps that pump it all up, 80 meters. They do the filtration, and then they've created these fantastic wetlands. Now, this was it was a 20-year program, cost billions, but the Thames now is starting to get life back. The area, the wetlands, are all growing like mad around Beckton. It's absolutely fantastic, and I've put the course along there through London that they've done it, and it took a lot of work, and it was really outside the box because London, very historical, lots of Roman stuff, so they had to go really, really deep under the subway systems, under the network rail systems, everything, and you can see there the profile, and it's been a huge success. And the guys who present this for Thames Water, it's a tick in the box. So what happened was, these are just examples inside. Colossal project. Guess what they've done? They've done the same thing in Japan. They've done the same thing in Paris because it works. You've got these huge metropolitan areas, and they've said, we've got to really think outside the box. It's a lot of money, but you're upskilling, you've got fantastic labor, you've got a lot of good references now. And they can actually use pipes inside as well to do other parts as well. But this is all for that. And the UKSTT, we took people visits to see the actual work going on. It's incredible. So here's the result. This is the treatment plant. The treatment plant is there, but look at all the beautiful wildlife that's encouraged to live around there. So you're really making a beautiful environmental impact. So this was the one in Paris, which it's slightly smaller, but they've recognized it's another way of thinking outside the box, using trenchless solutions to basically think about something else. You could keep repairing the pipes, but the volume going through it is too much. So you have to think about something else. So this was in France, and there's a similar one in Japan. So going back and just having a little bit of a summary is that since the 70s, trenchless technology has been around. There's actually some techniques that were long before that. And it's a multi-billion-dollar business. But there's also been a lot of innovation and expertise. And when people are starting to understand what the problems are, so talking to the cities, talking to the asset owners, and understanding what their problems are, population growth, etc., then developing technology to highlight and work with that. Also, a lot of testing has been developed. And each country usually has its own testing techniques. Some people like to use the American system. In Europe, we don't. We prefer to use German and British systems. In Australia, use the same. But we're providing a long-term, not a quick fix. There's no point because if you just do a quick fix, it's going to break 6 months later. Look at the long-term, plan it, and do it right. So we've got there's increased global warming, and we're going to have these extremes all the time. I mean, there's been no rain really in UK for probably 3-4 months. We've had hardly any rain at the moment. And the reservoirs are drying up. France, and you've probably seen on the news, the fires and all the rest of it. But we've got to adapt to that. Australia, first time they had a lot of snow. They never had the snow. And they were getting tons of snow. Here, you get more rain, which Chile was notoriously a very, very dry country. Now you're getting more rain. It's having to work with all of that. And these tools exist. But one application, like a CIPP or something, doesn't fix everything. It's one tool in a box of many tools. And there's so much new innovation. You'll see out here companies who've got relations with European companies or American companies, and they can bring all of this in. But we're also looking at not just the technology, but it's the application and everything else to bring down net zero. So we've got an environmental friendly solution. We always say, work as a team. The guys I work with here who are fantastic, they're friends, we work as a team. I listen to their ideas, I meet the end clients, we say, is this the right way or is it the wrong way? Let's work as a team and see what we can do. And then basically learn from other people and work with other people, and then things will move forward. And that's a snapshot of everything, so hopefully that was of interest. It's okay?
Thank you very much, Ian. I'm going to take 1 minute to translate a little bit of what you said to maybe some of the audience maybe didn't get it. And if you want to,
I do.
Drink water after you spoke like 25 minutes.
Gracias.
Le decía que me voy a tomar unos minutos a petición de la organización para hacerles un pequeño resumen quizás de lo que nos ha mostrado nuestro invitado, que ustedes se preguntarán qué hace una profesora de Derecho acá. Bueno, yo encuentro que la tecnología realmente, technology is what it's going to save us. O sea, la tecnología realmente es lo que nos va a hacer la diferencia, y desde el punto de vista de la regulación, el derecho tiene que hacer las cosas más fáciles, no más difíciles. Sí. O sea, soy un abogado atípica quizá, que creo que tenemos que ser parte de la solución. Ian Ramsey nos ha mostrado toda una tecnología de redes, de pipes, cañerías subterráneas para tanto agua, gas o aguas residuales, con todos los riesgos de no mantenerlas, de no hacerles una renovación probablemente, y de los problemas que tienen. Ahí la ministra hablaba de un 33% de pérdida, que se trata de la distribución de agua. Acá hay soluciones para poder reducir la pérdida de agua o mejorar también la distribución de aguas, sobre todo en las zonas urbanas, en que tenemos, como también nos explicaba, la presión de aumento de demanda, aumento de población y también aumento de residuos, porque no solamente necesitamos más agua, we need more distribution of water, but we produce more residue, right? Y eso no es, nosotros lo hemos visto, bueno, yo estoy pensando en como lo vemos antes, wastewater es un término, it's a term that says it's not used, right? O sea, podemos decir que aguas residuales es como agua perdida, pero gracias también a estas tecnologías pueden hacerlo a través de sistemas de tratamiento y reutilización. en distintos usos. También muy interesante la presión, no solo por la demanda de personas y recibos y efectos, sino también porque esto es un negocio, ¿ya? Esto es un modelo de negocio que tiene un mercado. En esta diferenciaste entre la pipe gravitacional, la de gravedad y la de presión, ¿cierto? Que obviamente deben tener técnicas distintas, en donde hay reparación, reemplazo y renovación. Me recuerda al reuse, recycle and reduce, right? Las 3R. Y quedé fascinada con esa tecnología del cure in place, que en el fondo es una lámina que se endurece, like lining that you make it harden inside the pipeline.
Yeah, we use a luminaire, light.
Con luz.
Light to cure.
Perfecto. El aumento en los mercados, bueno, todo el mundo, everywhere in USA, Europe, China, Japón, India, Brasil, esperamos más en Chile, con un negocio que, bueno, ya cada dato aumenta un 6% anual. The growth of the business, it's a 6% or so, you said.
It's 16%.
16%,
16.
16% al año. Tomen nota. Yo te tengo que, I have to ask, y el ejemplo de Londres, bueno, close to home, right? I have some questions. Pregunta, cortita.
Una pregunta.
Una o dos puedo, según lo que me avisa el reloj. Mi pregunta primero sería, ¿cómo puede facilitar la política y la regulatoria? Tengo que preguntarlo, I'm going to ask it in English, don't worry. ¿Cómo puede facilitar la política y la regulación esta tecnología? How can regulation, law and politics can ease your work and make more approachable, lo haga más cercano a las personas que tienen, estoy pensando agricultura, no solamente las grandes redes, pero también quizá agricultura. In Chile we're so used to open trenches.
I know.
En Chile estamos muy acostumbrados en la agricultura a los canales abiertos, ¿cierto? Que se ensucian más, reciben más residuos. ¿Cómo nosotros podríamos, law, and all the politics that...
No, we don't do the politics.
They've already left.
No, to be honest, if you go with the traditional way, it's a lot more expensive.
Yeah.
Okay, so you basically, it's not just the job of digging it up, it's the social cost. So you're blocking a road for a week. So the people can't go to work, they've got to go a long way around, the noise and things. Trenchless is around about less than half the cost of doing it with trenches. So say a trench was 100%, doing the same thing with trenchless would be maybe 30%.
Okay.
So you're saving 70%.
Yeah.
And you're upskilling the labor, you're being environmental, and you're giving a long-term solution. And trenching, you've got to sometimes dig.
It's simple.
Yeah. The problem is it is simple, but it takes too long, and it costs too much money, and the social cost. If you're a political person, you want to keep the people happy. Okay?
Yeah.
So if they are happy, because they're not getting disrupted, they're not got noise at 3 in the morning.
Happy people, happy life.
Happy
like
life.
Happy wife, happy life. Like,
Correct.
Okay.
Yes.
Bueno, ella nos dice, y tiene razón, I'm going to leave that out, but, que finalmente las zanjas tradicionales que nosotros estamos acostumbrados, abiertas, pueden ser quizás menos costosas, we could think that's less difficult, que son menos difíciles de hacer porque estas son más tecnológicas, pero a la larga las trenchless significan menos costos de mantención, más eficiencia y además tienen efectos ambientales positivos. Yo estoy pensando, I'm thinking, every time there's a flood or a rainfall, all the trenches spill and we have a lot of problems with the things that people put in. Tenemos muchos problemas muchas veces de personas que echan cosas, tiran cosas. They throw things, like big things.
I mean, you'll see, if you go in the hall, you'll see one is like where you have to dig. There is a really innovative way they're using dogs.
Yeah.
And the dogs smell the leak, where the leak of the water is, but they'll sell exactly where that is, and then they can dig at that point. Not here, just at this point. So you'll see a dog called Suki out there, and Suki is the most innovative way.
I saw him, the big dog
Yes,
that was
dog.
inside the water when we got there.
Yes.
Oh, wow.
Now what happens is in Chile they've developed a technique which only takes 6 months to train a dog. In France and in the US it takes over 2 years. But the techniques here, and one dog can save 65 swimming pools full of water within less than a year.
So, my question, how can we make it easier? How, with subsidies, with incentives, with, no?
Education.
Education. O sea,
The most important is it's giving the people an understanding. We're doing a job in Mexico in Coca-Cola. Coca-Cola, a lot of money, but they have a problem with production. They've got to have a quality assurance.
Yes.
So they didn't understand what they could do. They're going to dig everything up and close the plant down. But no, then they understood through education there was a trencher solution.
and so, hacer conocida, make
Sí.
known this technology and easier to access maybe
Sí,
for, oh yeah. ¿Cuál es el rol de la información telemétrica en estas redes? The role of information, data and control through monitoring systems. We're in the era of the AI, the artificial intelligence and the data. What's the importance of this?
Events like this are fantastic. And I congratulate Chile for doing the event like this because it's an education and people are understanding. There are events all over, you know, I mean, places like America where it's very common, Europe, but places like in Brazil, they don't do so much. Here in Chile, it's really starting to gain ground. I'm really, really impressed. And the quality of the labor here is excellent. Some really innovative teams, and they're thinking and they're planning things. Colombia is really doing quite well.
Colombia, Chile.
And then Peru is coming on maybe in the future, but Chile is a really, I've seen in Chile in the last 8 to 10 years, incredible.
O sea, los últimos 8 o 10 años está muy impresionado con Chile, lo cual es bueno, porque estos últimos 8 o 10 años han sido difíciles también en otros temas.
Unbelievable.
Así que bien. Y esto, ya me dijiste los datos de reducción de gasto, reduction of cost. Is it very expensive to change? O sea, because, you know, they're going to ask you, how much it's going to cost me and the time, for example. Okay, to stop the sewage or to stop it's really costly.
Every case is different.
Okay.
So sometimes, depending on the job, you know, we assess the job.
Okay.
We say, okay, you've got to do this, you've got to do this. And you can put a budget about this.
Yeah, so es un presupuesto para...
Yeah, but you've got to look at the long term as well.
And a timeline.
Correct.
Okay.
And a lot of this can be quite quick, but in some projects, it does take time, you know?
Obviously.
But you've got but it means that once it's done, the person can sleep at night.
Okay, great. Wow. Thank you so much for showing this.
My pleasure.
Gracias por contarnos todo esto, realmente impresionante. Y insisto, desde el derecho,
Gracias.
la tecnología es lo que nos va a hacer la diferencia y aquí podemos reutilizar. We have, for example, estamos pensando en una ley to reutilize